Geometry section 11.4, volume of prisms and cylinders. We'll start with a simple formula, V equals BH, a reminder that capital B stands for the area of the base that is to be distinguished from lowercase b's that you'll see in other places that also stand for base, but those are lengths. Capital B is to remind you that it's an area, a two-dimensional area, and H is then the height. We will use one formula for everything in this chapter, in this section, and this is the formula. If you read your book, and I hope you do, but I know some people don't. If you read in your book, you'd see a separate formula for a cylinder, and it's similar because it actually is the same as this formula, but they've substituted pi r squared in for b. Rather than doing that, as has been kind of the theme in this chapter, we like to keep the number of formulas low and have you make the inference yourself. If it's a cylinder, that the base is round and that's a circle and that area is pi r squared. Okay, so we're gonna derive everything from this formula. All right. For starters, this is the best picture that I could come up with that I could clip off of the internet of these blocks. Now, we won't find the area of something like this because it's not consistent from bottom to top. So really, just right from the start, I want to just take these out. Right, just pretend like these blocks aren't there. All right. Now, and obviously we're going to get more complicated than this, but this is, I think, a really good way to explain what we're doing with volume. By the way, volume is defined in your book as well. It's just the space that a figure occupies. And as far as units goes, now we will start to use units that are to the third, right? So meters cubed, inches cubed, miles cubed when we're talking about volume, because it's a three-dimensional calculation. You think about, just to make a distinction between surface area and volume, I'm sitting in my classroom right now. I mean my basement. I'm sitting in my classroom right now, and as I look at the walls and the ceiling and the floor, that's surface area. If I were to fill this room with something, bubbles or something, not water. If you were thinking water, that was not very nice. If I were to fill the room with something, that would be the volume. Okay, something very different. And the area of the floor is something that I could calculate if I needed to put new carpet in here. That's two-dimensional. Filling the room with something is three-dimensional. That's why it's meters cubed, miles cubed, whatever. Okay, so let's suppose, you can't see behind this figure. Let's just suppose that it's one layer thick, okay? There aren't more blocks behind. Then we'd say an aerial view, if you will, and pardon my drawings here. This is as good as I could make them. An aerial view of that would look like this, right? It's just 5 blocks. And if we were just calculating the volume of the first story, if you will, if you think about this like a building, it's a 4-story building. If we just calculated the volume of the first story, it would be 1, 2, 3, 4, 5 by 1 deep by 1 tall. Okay, well, that's 5 times 1 times 1, which is 1. If I added in the second story, then you would double it, right? And if I added in the third story, then it would be triple the first story. Again, I'm talking about stories like in a building, like levels. And if I added in the fourth one, then it would be 4 times the first one. In other words, 4 times 5. Okay, so this is the way we'll calculate all of the volumes in this section. If you can find the area, and I mean to say area, the area of the base, well, then you can just calculate that by how tall it is. That brings us our formula. Capital B is the base, H is the height. Okay, so let's practice that a couple times. Here it says find the volume of the prism below. Okay, now you probably learned once upon a time that for a rectangular prism that this is, or a box you may have just called it, length times width times height. And I'm not against length times width times height. It's just limited to that specific figure, a rectangular prism. And so certainly you could get the answer here by saying 3 times 5 times 5. But I'd like you to see this from a little bit of a different point of view and use this formula. And the area of the base would be 3 by 5, 15, and the height then would be 5, which is perpendicular to it. Now, in a previous video, I already went over, when it comes to rectangular prisms, what the bases really could be. I just decided to call the bottom and the top the bases here. We could do it differently. In any case, It's one of those areas of one of the rectangles times that length that's perpendicular to that area, that base, okay? And 5 times 15 is 75. So this would be 75 cubic inches. Once again, I think I said this in a previous video, please don't do this. That's not correct. That looks like 75 cubed inches. That looks like a really, really long length and not a volume. Don't do this. 75, you can say cubic inches, but the way you write it is like this, inches to the third. Unfortunately, that was too easy. Let's try it with a triangular prism. Now, once again, a little bit of a side note. Students will sometimes, in error, think that the base is this rectangle right here. That is not the base. The bases, plural, on a prism are always congruent parallel faces. Congruent parallel faces. There's nothing parallel, nothing else parallel on this figure to that rectangle. The parallel faces are actually the triangles. These are the bases, that one and that one. It's a triangular prism. The height is 40. Okay, now this is not as simple as the last one in that we can just calculate a simple area and then multiply by 40 and it's done just like that. We're going to have to do a little bit of figuring in order to come up with the area of the base. We do have a formula, A equals 1/2 BH, lowercase b standing for base as a length, and H. Notice that it is a right triangle. So if I decide to call 20 lowercase b, this other side is perpendicular to it would be H. All right, now think about that for a second. How could we find H? Would everyone agree that this 29 would also apply here? This length is 29. Isn't this a Pythagorean theorem problem? So we could go 20 squared plus H squared equals 29 squared. And if you did the Pythagorean theorem on that, what you'd find out is that it's 21. If you solved for H on this, you would find out that it is 21. Okay, so H is 21. That H, let's just be clear now, that H is not the same H in the formula that I gave you at the beginning of this lesson. This H is the height of the triangle. The height of the prism is the 40. Got to keep those straight. We have to call it something. H makes sense. It stands for height. But we're talking about two different heights. This is the height of the two-dimensional triangle. 40 is the height of the three-dimensional prism. All right, here we go. The volume then is capital B, H. And that capital B is actually this area. That's what's going to go in for B. And this was 1/2 20 times 21. Now, if you want to go ahead and get that number and plug it in, that's fine. If you want to bring the formula in, this is what I'm going to do right now. 1/2 20 times 21, that's my capital B. And then my height of the prism is the 40. Okay. An acceptable way to do the work is what I'm saying is if you went ahead and already did this, right? Half of 20 is 10. 10 times 21 is 210. You could just have 210 times 40. And 210 times 40, I believe, is 8,400 meters cubed. Yep. All right, so I've talked a little bit about the appropriate amount of work. Obviously, here's your answer. This line right here would be the line of work that you would really have to show to prove to me. Obviously, you're doing this at home anyway, and I'm not going to see your work, but this is what you would have had to show me to prove that you knew what you were doing. A couple more things. Okay, so volume of a cylinder. To us, again, a cylinder is just a round prism, a circular prism. So I'm going to go with the same formula, capital B times H. Okay, I'm not going to use this formula to start. I'm not going to remember that formula separately. Rather, I'm going to use this formula. I'm going to recognize that this is a circle, and then I'm going to plug in pi r squared for B. Okay, and then it should be pretty easy from there. Now, there can be a little bit of confusion sometimes with the way they point here. I believe that 16 is pointing at the whole length here, the diameter. So I believe the radius is 8. I don't think any of the book problems or Socratic problems are confusing like that. But if you interpreted that as a radius, you're going to get a different answer. I believe they're saying the diameter is 16, so I'm going to use 8 for r. Pi times 8 squared, and then the height is just the 9. Sorry for my starboard's messing up a little bit. I don't usually write like a 7-year-old, but it's a little shaky today for some reason. Now notice that the answer says the directions say leave your answer in terms of pi. So I'm just going to do 8 squared times 9, which is 576, and then leave my answer in terms of pi. 576 pi feet cubed. Yeah. All right, now a little bit more. In your book, I've actually made a drawing of it on my starboard as well. I don't know how good the drawing is, but I think you'll get the point across. These are supposed to be identical figures right here, except that it's like a stack of paper, and in this one, the stack of paper has been shifted to the side. So it's like somebody pushed the top over. There's a better drawing on page 625 of your textbook if you don't like my drawing. But basically, we want to point out that this figure would have a certain volume, and if I came here with my hand and I just knocked all the paper to the side so that it looks like this, the volume didn't change, okay? So when we say that volume is capital B base times height, and the capital B base is, let's just say, the square that is the top of this figure, the height is still the height, right? So whether the height is vertical like this, or whether the height, or I guess what I should say is that length is vertical, or whether it's slanted like this, the height is still vertical. So the height is like this, so that it's perpendicular with the ground, floor, table, whatever it's on. The term is right, so a right prism would be straight up and down, a right cylinder would be vertical, and if you set it on its base, and this would be not that. I think they might call it oblique. But it doesn't matter. We still want to use the height that is perpendicular to the bases. Okay? Now the last thing then is something called a composite space figure. That's a definition in your book. Basically, it's just a 3-dimensional figure that's a combination of 2 or more simpler figures. Okay? Something like this next example would be a composite space figure. It's not a rectangular prism. It's not a cylinder. It's none of those. It's a combination of a couple, or 3, I think, actually, rectangular prisms. Now think about how you would do this. What if you were taking the SAT or the PSAT and you came across a problem like this that wanted you to find the volume? Think about how you might go about that. A lot of times when I ask that question, what students will come up with is, okay, we'll section it up, and we'll draw on it like this, and maybe like this. And there are a couple of different ways you could even portion this up and calculate 3 separate volumes. And if that's what you want to do, that's great. You'll get the right answer. I'm all about you getting the right answer. Okay. Another suggestion that I will often get is students will say, okay, calculate the volume of the whole thing, right? Do 14 by 10 by 25, and then just take out the shaft that goes down the middle there that is not part of it, right? And again, I'm happy that if you came up with that, that's great. I'm not going to use either one of those methods because I want to stick to the theme of capital B base times height, okay? And what I'm saying is if I can find the area of this right here, this base, then I could take that area, let that be capital B, and multiply it by 25. So I am going to do what I suggested a minute ago, but I'm not going to section up the whole 3-dimensional figure. I'm just going to section up the base. And this would be 4 by 6, so this is a 24 square centimeters, right? Centimeter squared. This one also would be 24. This is 6 out of 10, so this would be 4, and 4 times 14 is 56, okay? So I'm just going to calculate the base as being 24, 56, and 24. A little bit of quick mental math here, and that is 104. So the volume is 104 for the base times 25. And I better use a calculator for that. 2,600 centimeters cubed. Okay. Now, again, regardless of which method you used, any of the three, you should come up with the same answer. That is consistent. 2,600 centimeters cubed. See, they didn't even do it the way I did it. They did it the first way that I suggested. And there's your 2,600. All right, thanks for tuning in.